In this video, we're looking at HEBI Robotics. We'll look at their modular actuators, run them through their paces, and build this robotic arm. Stay tuned. This channel is a lot of things to me. It's a catch-all. I share some of my favorite technologies, cool machines, demonstrate fabrication techniques, and everything in between. So when I convinced HEBI Robotics to send me over some of their actuators to work with, I was thrilled. In this video, we'll look at modular robotics, what makes them cool, then apply them to demonstrate what it takes to make this complex 6 degree of freedom robotic arm. But first, let's talk about HEBI Robotics. HEBI Robotics was founded in 2014 by a cross-disciplinary team in the world-renowned Robotics Institute of Carnegie Mellon University. The company is a spin-off from CMU's Biorobotics Lab, led by Professor Howie Choset. His cutting-edge work in biorobotics is fascinating to say the least. In 2016, HEBI released its X-Series platform of modular hardware and software tools, now used by dozens of global universities, researchers, and industrial partners to create custom, world-class robots quickly and easily. At this point, you may be asking yourself what an actuator is. By definition, it's a component of a machine that's responsible for moving and controlling a mechanism or system. When we talk about actuators, we can put them in a couple fundamental categories, those being linear and rotary actuators. Linear actuators push and pull, whereas rotary actuators twist on an axis. They can be combined into complex multi-jointed assemblies to perform just about any movement you can think of. The modular actuators that HEBI makes are rotary actuators, but they do a lot more than just that. These are best-of-breed actuators loaded with sensors that enable controllable position, velocity, sensitive torque control, as well as 3-axis inertial movements. And all that adds up to some amazingly complex modular devices that allow you to build intelligent and complex robots that behave more like an organic object than a simple servo motor. Similar to a closed-loop servo on steroids. They're cross-platform, don't require calibration or homing, have a through bullhorn in their rotational axis, which allows these things to be daisy-chained and wired up for just about any purpose. With that foundation, let's talk about the different models they sell. The X-Series actuator is their original design that comes in 6 different models. Each model is packed with the same sensors and accuracy, but the ratio that drives the actuator ranges from super fast with low torque, like 90 RPM with 1.3 Newton meters, to slow and strong at 15 RPMs with 16 Newton meters. In terms of accuracy, these all have angular resolution of 5,000th degree and torque resolutions of 0.1 Newton meters. With a backlash of plus or minus 0.25 degree, these actuators are strong but have finesse while having accuracy and precision for most robotic applications. In addition to the performance, these are small computers designed to be networked together to create advanced assemblies. Aside from the X series, the new R series have even more to offer with IP67, which is Ingress Protection 67, rated enclosures. These offer environmental protection for adverse conditions that you may have in your environment. So this is about running underwater in moist and humid environments where those motors need to survive. In addition to the actuators, they offer an I/O board which provides integration of general purpose I/O sensors, probes, lighting, and other accessories to your design. They all communicate through their common API, which makes it easy to integrate into the system. Accessory-wise, they offer their own brackets and connectors that, when used as part of the robotic system configuration, allow the drive chain to compensate for known mass and inertia associated to any combination of their components, actuators, and connectors. They've really thought through a lot of the complexities of robotics here. Along with their pretty incredible specs, they offer great configuration analysis software and SDKs to build and test a project pretty quickly. These things are basically a robotic erector set that you've always wanted. So what's the catch? Well, these things are industrial and science-grade modular components, and a lot of work from some incredible teams have gone into their development. And as a result, the cost of entry on a setup is quite pricey, and a complete system starts at around the cost of a modestly priced vehicle. At the end of the day, if you need this level of capability and precision, then you'll likely have a value stream to justify the savings that this technology will bring to your project. That said, enjoy the video. Today we're going to demo the actuators, run them through their basics in preparation for a couple amazing projects. Before that, let's talk about other aspects of the system. To control the devices, you'll need to tell them how to behave and what to do, and for that, HEBI's designed some great and comprehensive API SDKs in multiple languages, namely C, C++, and Python. So if you want to dive into the code and program some very specific behavior, you're good to go. The SDKs are high level and make programming the complex aspects of the robotic system with a great deal of simplicity. On the other hand, if you prefer to use like MATLAB or ROS, the robot operating system, then they have modules and plugins to integrate directly with those systems as well. Plus, there's a vast community of contributions to produce some really advanced work in those platforms. If all of this is overwhelming, their SDKs have dozens of examples to get you started, ranging from basic movements to advanced kinematics, feedback, and alternate control strategies. They also have a tool named Scope, which is a useful little tool to analyze, configure, and tune the performance of the HEBI devices on your network. Multiple scopes can be brought up simultaneously to display the actuator telemetry in your system. This tool alone is incredibly useful and easy to get you started fast. Okay, so before we get started, we'll have to make a few decisions around what the mechanism will be, how we structure it, and HEBI has just about everything you need to accomplish that. In addition to browsing their store and reading the datasheets on their actuators, HEBI has a plethora of documentation to understand the complex faculties and sciences behind mechatronics and how to use their components. With no prior experience, I found it easy to come up to speed on the physics, technologies, and programming interface, which says a lot about the design and engineering that went into the system. To get started with designing a robot, the easiest way is to use their online configurator app to build and connect the specific HEBI components. Of course, you can build your own structure in an external modeling system like Fusion 360, but that gets complicated. To make things easy, we'll use the tool that can be found over at robotbuilder.hebirobotics.com. It's an online tool that'll help you assemble all these components in no time at all. For this setup, I'll be creating this 6 degree of freedom robotic arm, and for that, I just need to add the actuators and brackets and assemble the arm in the configurator. One of the neat features about the configurator is that in addition to simplifying the task of determining the necessary parts, it also has the ability to export your robot to a config file. It's an HRDF extension, which stands for HEBI Robotics Definition File. It includes all the connectors and actuators that comprise robot. This file is later used with the software to tell the API about the design of your robot. The SDK algorithms will take the actual weights and orientations into consideration to determine the mass and inertia of the robot assembly with the planning actuator movement and efforts. This simplifies the complex science of building and using robotics. Once the arm assembly is complete, you can test the arm movement, export the HRDF file configuration, and even get a quote from HEBI. It's pretty neat to explore the options and capabilities before you spend any money. With the basic design complete, next I assemble the real components to create the arm that was designed. For that, I start with an 80-20 extrusion for the base. This was mounted to my bench, and from there I assembled the arm using the actuators, brackets, and extensions used in the configurator. Initially I went with 500mm arm lengths. Once complete, I realized that size was a little overwhelming. I cut those in half to reduce the scale and mass of the arm to better suit my environment. Once assembled, the actuators are wired serially with RJ45 network cables and a 48-volt power supply. That'll power all the actuators. Total assembly time was around 35 minutes. Next, I 3D printed joint covers to clean up and protect the wiring. Side note, HEBI offers CAD models to all of their components, which is nice, so you can import them into your own design or fabricate some and save some money. You can find all of these over at cad.hebi.us. Now, with the arm fully assembled and connected to the network, I open up the scope application and configure the actuators. For that, I need to assign a family and name to each of the devices. While they all share the same family, each actuator gets a unique name to identify it on the network. In this case, the actuators were named base, shoulder, elbow, wrist 1, wrist 2, wrist 3. In scope, the names are all assigned to the devices, and the actuator family groups the devices neatly together. Before we get too far along, let's take a quick break. This video is sponsored by Altium. It's the software I use to design my project circuit boards. If you haven't taken the chance to download a free copy and see what you're missing, I've put links in the description. With the Altium designer, creating these projects is a piece of cake. It's fast, accurate, and fun to use. The efficient workspace has some of the best features in the industry. Through all phases of your development, you'll be empowered to do your best work as you grow into its more advanced capabilities. The link below will allow you a free trial of the software so that you can check it out and see what enterprise class ECAD feels like. Now back to the project. Okay, so back in scope, we set up, analyze, and tune each actuator's behavior and performance. We can open scopes and view any model attribute on a rolling time series graph. This maps the actuator's actual versus planned performance and all helps us to tune and refine the device's performance. Gains control the PID loop for each of the actuators. There's a lot of options and it can be complex and tedious process to get all just right. This varies from robot to robot. It depends on the physics and design of your machine, which may take some time to tune out all of the movement anomalies caused by the mechanical resonance and just behaviors that you're looking to achieve through your assembly. Once all the device gains are tuned to your liking, you can export them as a gains XML file. Now this file is used as input to the SDK API to configure the device movements. So now that I have an HRDL and a gains file to define how the robot's connected and controlled, I dove into Python examples to run some quick tests. For initial testing and demonstrate some advanced behavior, I dove right in with the teach and repeat example. This script works by leveraging the HEBI Python API to read feedback from all the actuators in the arm and store them as a waypoint. You can position the arm in multiple positions, capture waypoints, and then play them back. This is a real neat demonstration that immediately showed how powerful these devices actually are. Cool, right? Now, granted, there's a lot of room for improvement in tuning the PID values and gains, but it's close and saves a ton of time in the engineering process. To give you a better idea of the range of motion, I took some time to demonstrate a few other movements. Check these out. While robotics is a complex and evolutionary field, this is a super capable system that allows you to get up to speed fast and create some really impressive robotic designs. So about 5 years ago, I developed a multi-axis robotic time-lapse gimbal. It was called the Steady Shotbot. I'll show you some of those clips of that here. While it was fun, it was not nearly as capable as this device, and it took weeks of development over the hours that I've invested here. Moving forward, my main project for this robotic arm is an intelligent, real-time robotic camera gimbal to capture some work I do in the shop for both real-time and time-lapse. Real-time would include visual object tracking, and while the parts are ordered, it may be pretty heavy to compute on a Pi, but we'll see how that works out later. Another challenge of this design is that the system requires a computer to run the scripts against the API, which makes it awkward to set the waypoints and the playback movements from a PC. So if we can do that from the Pi, that would be great. As you can imagine, on the drawing board is a Raspberry Pi computer vision brain, a custom interface, and lots of programming to complete the intelligent, mobile, self-contained robotic camera gimbal. So while I flush out all the technical design work, leave some comments below and let me know what you think about these actuators. I don't really know how long it'll be before HEBI wants their actuators back, but they've been really nice and a little hard work, and we'll get this done in the next couple weeks. Hopefully you enjoy this high-level overview of the HEBI Robotics actuators being put to use. It was fun to work with this technology. I'll leave links below to all the components I used in this video, so you can go play with the online configurator and learn more about HEBI. Thanks to everyone for supporting the channel. I also want to say thanks to Hardik over at HEBI for loaning the devices and making this all come together, without which it obviously wouldn't have been possible. That's going to do it for this video. If you're new here, hit the subscribe button and ring that notification bell. It'll help keep you notified as new videos come out. If you like this particular video, give it a thumbs up. It lets me know you care. Thanks for watching the video. Take time to share, leave comments, and in the meantime, be safe, have fun, and I'll see you next time. Hey, if you liked the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also, check me out on these other social networks. There's lots of cool stuff there, too.